fucking fun, shall we? Just changing stupid music. Alright, let's go. So, Pack Shinek has an array of integers. So, right, since he is currently learning how to calculate the floor average of two numbers, he wants to practice on his array. While the array has at least two elements, practice will perform the following three step operations. So, three steps. So, it must be 1 to 3. Okay. So, pick the indices I and j. I and j can be the same, looks like, and they also they cannot be the same actually. Okay, append ai and aj. To the end of the element, remove ai and aj from the array and concatenate the remaining parts of the array. For example, suppose that a equals 6 elements, and suppose I equals 1 and j equals 5. So the result will be 1 plus 6 divided by 2, and that'll be 3. Concatenate that to the last elements and remove ai and aj. Looks like, right? Okay, if we choose I equals 4 and j equals 3, the result will be, let's see. So here, I'm assuming these are, zero index, I believe, right? So from this case, it'd be removing 6 and removing so 4 and 6, that'll be 5. Divided by 2, 5 divided by 2 is gonna be 2. Oh, is it 3? And it's given 3 here, so because I'm assuming this is 1 and this is 5. That'll be 6, right? 6 divided by 2 is gonna be 3. Let's remove 5 and let's remove 1. So it'll be 4, 3, 2, 1. And we're 3 because we're concatenated to the end. Or here. And so, and we get this array. If we choose I equals 4 and j equals 3, which is, I'm assuming is 1 index, so we're looking at 3 and 4 right here. We take those two elements, so 2 here, 1 here. That'll be 3. 3 divided by 2 is gonna be 1, I believe. Oh wait, sorry. Is it ceiling? Yeah, it's a ceiling. I forgot. So 3 divided by 2 in the ceil form is gonna be 2 instead. Since it's 1.5 here. Oh wait, floor function. Oh, whoa. Okay, so it's 4. Wait, so if we choose, so once we have this array, we're selecting j equals 3 and 4, right? 2 plus 1 is 3. 3 divided by 2 is 1. Oh, we're looking back at this array. I'm stupid. What the fuck? So let's choose 4 right here, and we're choosing 3. So 3 over 4 is 2. So 3 plus 2 is 5. 5 divided by 2, and floor operation is 2. So after all operations, the array consists of a single element. Find the maximum possible value of x. Okay, I got it. Nice. All right, boys, let's do it. So let's get some observations. Observation we can probably make about this is that well, yeah, I mean, I can probably see you're gonna be short since we're trying to find the max elements. Finding the max, we're probably going to sort it first, and it looks like it's gonna be a greedy problem since we're finding the max element. So we already know it's gonna be greedy. Well, not greedy yet, but let's just assume that's gonna be greedy. Damn, it's already 5 minutes in, bro. Okay, I'm gonna spend, let's say, another 2 minutes on the problem. So we're given a test case right here, 1, 7, 8, 4, 5, and the output's gonna be 6. X is gonna be 6. That's the maximum, right? So I guess doing this, from what it looks like, we can choose any element, like I and j can be any element. But let's just make things easier and just sort it for a time being now. And let's just do this first. 1, 4. It's gonna be 5. Part 5, 7, 8. Then 4 gonna be 2, 5, 7, 12. Then 8, 2, 6. 2, 6, 8, 8, and 4, 8, 4, 16, 26. Okay. So from what it looks like, wait, hold on. Is it? What I did pretty much is just select the lowest element and just since n is equal to 50, we can just pretty much just select the lowest elements, I guess. And to do that, we pretty much just select the least elements. And I think we can just do that with priority queue. Yeah, I'll go over example one more time. So we're giving 1, 4, 5, 7, 8. We select the first two, perform the operation, which is 2 in this case, right? So it's gonna be 2 because 5 divided by 2 is gonna be 2, 4, 5, 7, 8. So we do this 2 here. It's gonna be 7. 7 divided by 2 is gonna be 3. 3, 7, 8. Do the same thing here. It's gonna be 10. Well, 10, 5, and 8. And do the same thing here. It's gonna be 13, and 5 by 2 is gonna be 6. So we're pretty much just kind of just constantly sorting and like just dividing by the last two, the earliest elements. Well, I can't really prove that's true since we're doing competition, but let's do 1 to 2, 5, 6. Here it's gonna be 7. 7 divided by 2 is gonna be 3, 3, 6. It's gonna be 9. 9 divided by 2 is gonna be 4. And answer is 4. So let's code that now. I guess here it looks like we're going to I think we can perform that with a set. Set of priority queue, which one's better? I don't use priority queues that much, but I guess we have to. Let's first get our priority queue. Oops, that's it. I believe priority queues are always going to be sorted, I believe. Let me just check it real fast. Let's stop right here. PQ 8.5. Nope. I was wrong. Oh, how do you? Damn it, dude. Am I gotta worry about the syntax right now? No. Just debugging. Checking if it works. 14875. It's still not sorted. What the fuck? Why? I'm wasting too much time here. It's 150, right? 150? Yeah, I'm wasting too much time. I guess we can just use a set. Set's way easier. Don't know why I'm just wasting stupid time. Set. And S2. Let's enter it. Okay, let's do it now. Okay, voila. Sorry. 0. So I guess while S2. What? Can you remove all this from it? It's a dumb value. Actually, no. I see. This is a pointer. Now, let's dereference it. No, I think it's just. Is this the right? Is this? Wait, hold on. Is this the right way of doing it? I'm cooked, aren't I? I am cooked. I don't even have to like cycle up the first two. Okay, she's a vector, bro. This is too painful. I did. How the fuck do? Oh, what you know? You can just do. It's a really. Well, what if I start? You know, let's start from Let's start from 2. Okay, so I didn't really perform the operation. I guess out here, then we see out a 0. That is such a ghetto way of doing things, but let's see if it works. No, not infinite loop, dude. Spent 15 minutes on this stupid problem. Oh wait, forgot it's not. I'm dumb. There. Let's see if it works. I should not be doing doing CF at all. Here it is. 5 4. Okay. It gives me 6 now. Let's see why it's giving me 6. Come on, let's go. Oops, did I just fuck up? Yep, I did. Oh, let's. I forgot to sort it. Let's sort here first. Since n equals 50, we can just, just do the brute force solution. Let's try one more time. There we go. Alright, let's go. Solved it. Let's check it out. Let's see. Alright, let's go. Let's do B first. Then see, it's in key right now. So you're given an array of n positive integers and then an integer x. So you can do the following two-step operation. Do the following two-step operation any number of times, and choose it. Oh, max, nice. Pretest pass, nice. Okay, so find the maximum max of a if you perform the operations optimally. Okay, so choose an integer, increase ai plus by x. In other words, ai equals ax plus x. So we're given x by the way, and we're going to choose find a maximum value of x if you perform the operations. Okay, I see. So we're given pretty much this and x. So n equals 3. So n equals 3. We're given. Let's just use 0, 3, 2, 1, 5, 2, and we're given x equals 3, right? The minimum value right here, the max in this case is going to be so let's sort it. 0, 1, 2, 2, 3, and then what else is it? 5, guess 5. So we have 0, we have 1, we have 2, we have 3, and we don't have 4 though. So max right now is going to be 4. Now we got a question though. Is there a way to, I suppose, get 4 with x equals being 3? Well, the only way to get 4 in this case is it's with 1 right now. And because 1 is already in a special place already, we can't really use 1 anymore. We have to so therefore that's kind of where we stop. And let's see, in this case, ai equals 10 to the power 9, and n is also 10 to the power 5. So we can't. So I think the highest complexity we can have is log n log n. So yeah, from looks of this, we can kind of just prove that we gotta like cycle through every single number. I guess from wait, we can't do that actually, can we? No, because it's 10 to the power 9. So I guess I don't think log n is gonna work. Yeah, it's not gonna work, is it? No, we can't, because we can't use log n, can we? Because I'm trying to check every single number from 0 to the highest value. Since highest value is yeah, okay. So I think we can do another. So what kind of operation can we actually do? Is there a way we can kind of is there a way to look for the elements themselves? So again, we know that we're looking for the maximum value of max. So maximum value of max. Maximum can kind of imply that it's greedy, I suppose, but we can't really make that assumption because we don't really know much about this problem yet. But we do know that let's work on another case to maybe like clarify it, to help us clarify. Okay, so we're given another test case is 1, 3, 4, 1, 0, 2. So let's sort this because it might be a bit easier. 0, 1, 2, 3, 3, 4. 0, 1, 1, 2, 3, 4. Sorry, I know I'm speaking fast. I'm sorry. Just I'm in a contest right now, so I just want to get you over it. So what's on my mind might not be like conveyed properly. So I apologize in general. Okay, so now we know that the max right here is x is gonna be 2 by the way. So here we have 0, we have 1, we have 2, we have 3, we have 4, and do we have 5 though? No, we do not. So wait, can we get 5? That's a real question. Well, we know that we can kind of so with the question right here, it implies that we can do this any possible number of times. So in this case, we can get 0. We can kind of from an observation we can make is we can kind of add any factor of x into the equation. So we can kind of whatever 2 times x, 3 times x, I times x. We can add any factor of x to any number in order to and we can put in an array too. So we can kind of put, so we can get 1, 2, 3, 4, and we can just add this by 2 times x, and we get 5. So in this case, we can get the max here is going to be 6. That's good. And let's do the last one. Last one is it's only adding, by the way. So last one is let's see, 2, 5, 10, 3. Let's sort this 2, 3, 5, 10. There's no 0 here, and there's no possibility you get 0, so the max here is gonna be 0. Okay, let's I think, yeah, it's kind of straightforward, but it doesn't. The test case didn't really help me. Let's generate ours. So I guess we can start with just doing, since the minimum number is 1. I guess the minimum number, since the minimum number is 1, it's simply just, if it's not 0, then 0, else 1. Let's give it a bigger number. If 2 numbers, let's give it 0 and 1. Max is here, obviously is 2. Let's see. And give it 3 numbers. Let's say I forgot to add x, by the way, but it doesn't really matter. Okay, so let's give it 2 or 3. Give it 0, 1, and 0. And I guess so x equals 1. If x is equal 1, we can, the answer is pretty much the size of a. The reason being is because any factor, or any one is like the factor of 1 is the factor of every number, so we can kind of concatenate every number to, so we can kind of like basically have the array be every number, only if it's I guess only if it's like just lesser. So I guess that's not really good proof I can make. So no, cancel that. This is absolutely wrong, because I've made it. Because the case of like 0, 1, 5, it's not. The max is equal to 3. Sorry, 2. Anyways, let's keep going. So down here, I guess from test cases we just made, you can kind of make the assumption that x is going to be significant. Well, obviously it is, because it's and x is from 10 to the power 9. That's the highest number x can be. Okay. I can't find any other solution to this problem. I want to try binary search, but binary search, you need to kind of. I think binary search might work. I guess we can so for every single element we can check if it works. So in this case we just kind of just But okay, so I'm thinking of binary search. The binary search is it's going to be log of I guess so for binary search, my algorithm simply just so from every element from 0 to 1, 10 to the power 9, right? Start from the middle, right? Start middle. Whatever x is, we try the number, right? We take the elements, I guess, and see if it's possible with x, right? And x and array, xa, right? And to find out whether it's possible, basically we just given numbers x, y, z. Let's give it a, b, c, or not, fuck it. Random numbers 0, 1, 2. We're gonna try if max is possible, right? Is possible. Max of x is possible, and if it is, then we so because we're trying to find a maximum, we just simply just beat mx equals max at the moment, and we keep going. And I guess we left equals mid plus 1. Now the thing is, right, so this is I guess this array right here is most likely going to be so I guess the possibles is the question we need to kind of answer. Like, what is the operation here? Operation cost. So in order to find whether max is possible, right, we need to know I guess to find whether max is possible. We simply just kind of just look for, like, because we have a value x here, right? X is 2. We simply just gonna, like, so we're gonna check if 0 is here, 1, 2, 3. If a number is missing right here, we're gonna do we're going to look for any number in the back and see whether but the operation cost is going to be really, really heavy, because what if there's like so many numbers in the back where that's going to be heavy? So we can't really do that, can we? No. So there's no really fun way of trying to find a max. So so I guess no, because that's gonna be I think it's actually possible though. Yeah, I think it is. I think it's possible. Because is this gonna be this is just n squared, right? Saying that we need to, like, find a possible max, I believe, right? Let's say, like, here we're gonna traverse back and see if there's any value that can fit this missing number, right? So once we look back, we can just yeah, it should be possible, I believe. Because this is just this operation would just be n squared, and log of a squared is just gonna be 2. It's gonna be 2 log of a, right? And that's sufficient. And it's gonna be 2 times 9, by the way. So it's still sufficient, but I just want to see, like, how the algorithm is gonna work. So is there a value where is it gonna take x right here, the question mark minus x, or any value of x right here, if it's possible, and if it's 2. So it's gonna be I times x, right? And if there's a value in map, or because we're gonna store it in map, if that value exists in the map, we gotta check the occurrence. If occurrence has if there's more than one frequency, let's put a frequency. I'm talking about frequency is more than 1, right? So here, yeah. Then it's possible, right? And we add a number right here. Well, what we're gonna do is we're gonna add a number here, and then the frequency of this, we subtract 1 by it. So yeah, I guess my algorithm, it's a little bit tricky to be fair with you, but it's simple for me to understand. I guess let's try coding it first and see if it'll work. So I guess x. And just, I'm gonna sort it. I said let's give it frequency. Wait, so that, okay, no, the highest value can be 0 actually. And then it's gonna be 29. Big ass number. So if this is max. And we're gonna put and snare equals, well, just to L, how do frick is the what's to avoid L plus R, I believe. L plus R. I'm if possible mid, and give it MP or frequency. Also, from my understanding, we need also mid frequency and also the array itself, right? I believe. If it's possible, MX equals mid. L equals mid plus 1. Else R equals mid minus 1. And once you get that, you can see how that's I don't know. And it's cool. Well, so we're gonna start from X, and then MP map instance frequency. Oops. Now we last one is CI. Okay. Okay, so I guess I just want to check if I'm doing everything correctly. So binary search, and also this is gonna be n. This is gonna be n squared, by the way. So we're gonna just check if remember that A is sorted, so we can just simply just check if so it's not, it's gonna be 189. It's eventually gonna stop, by the way. Actually, hold on. I guess we can pull auto. So, I don't check one thing only. Zero, 1, 2, 3, 5. Okay, it is sorted. So so what exactly am I even trying though? Oh, basically X, right? Oops, X is already taken. I gotta use the bathroom. It sucks. Okay, well, I was in the back from I thought about it for a second. So there's two cases, whether it is in, so it's whether if max is in frequency, or no, and y.fi. Well, there is, I mean, if there's a value, right? Well, okay, how was that? How about this? Frequency dot max is not equal 0. Because if it is 0, we gotta find if it's a possible way to get it. So we can just do max plus plus. If it is, then we just max plus plus. If max equals x, that means it's return. I mean, it's possible. Return false. And we're not assigning. We're just checking if it's equal. Check if it's possible to get it. So to check if it's possible to get it, we can just simply just remember the one here where we gotta check if we're basically like iterating backwards. So right here, the unknown question right here is I think the question mark value in this case right here, if max is not found in the array, or like the number, let's say like 5, or like in the example, the first example right here, which is 0, 1, 2, 2, 3, 5, right? If 4 is not found here, we're basically just check 4 minus whatever I times max, and so 4 in this case is going to be at current max right now. So we're just going to take max right now. We're just going to, because we might need max. Max. Let's go max, and then we're going to search. We're basically going to search if we're going to kind of iterate backwards, I guess you can say. I mean, you don't need to iterate backwards. I mean, you can kind of switch forward, right? It doesn't matter, because we're gonna stop if it's lesser than. So what we're gonna do is basically check if frequency dot temp minus, sorry, so we're checking basically if what's it, if I should be writing the paper what I should be doing first. Max minus times x is in the array. Actually, I don't think we really need. We can just pretty much do true, because it's gonna break regardless. And I guess the frequency is greater than 1. What we're gonna do is so because we're gonna take that value re times x, we're gonna take that value and just increase the max. And since it's true, we gotta break out of it. And also, if let's say I times x is greater than max, yeah, we definitely did not need times, by the way. Or greater than equal to max, then you can break this as well. But yeah. I guess I'm missing something. I'll see where I'm missing at. So basically I'm checking it for a way to get this is a really terrible way to, I'm just 118 right now, so I'm spending like 30 minutes on prompts on spot. So we should kinda check if next works. Which is good. So if the value is in the present, then and if it is 0, let's look back in the array and see if there is a possible way to form it, I guess. And if there is a possible way to form it, right? Then that's good. If there's a possible way to derive it by taking one of the previous elements and just adding it and getting the mex, that's good. If there, and this case is just basically and if there isn't, is eventually gonna fall here because yeah, I think this works, right? I just gotta like visualize it. Yeah, it should work. Oops. Still finish. Alright, let's try it. I mean, I have a hunch it's not gonna work. Here we go. So it's giving its infinite loop. Let's see why it's giving its infinite loop. Funny enough, I could use this sort count sort, but it doesn't really matter. But let's see why it's giving its infinite loop. And this should be, let's say if it ever branches here. Oh, it stops. It never goes under. That's an issue. Ooh la la. What's this? It's gonna be F8. Run to that. Run it more. Let's see. Okay, it's a low number now. Well, it still needs to go really low. Like it's gonna be the single digits. Wait, mid 2 is not working? Wait, really? I'll do it one more time. Sorry, it's taking way too much time. Okay. So mid 2 now. Let's step into it. Whoops. Nope, wait, what? Like step into the function. Why didn't it step in? I am confused. Why are you not step in? All right. One more time. Wait, is it because hold on. Okay, I see the issue. But let me just actually just since I can set the value, I can just pretty much do this. Man, debugging is such a big deal. So debugging is a hell of a. Let's go. So I guess here, if max equals x, return to. That's boom. Because it does not need to be up there. Let's see, 450. Damn it! It's here. Why is it giving me 5 here? Okay. Well, let's just do this instead. 1, 6 right here. Oops. Whoa. Let's set one more time. Voila. And how do we do this? So you don't have to search every single time. Okay, let's actually, since it's like, since it works now, we don't really need to Alright, so we're given 6 now, right? Mid equals 6. And it's wrong. Okay, R equals 12, so now, let's set a breaking point. Well, it's such a ghetto way of doing it, but again, we love the ghetto. I don't, by the way. And I'm not ghetto. But I am black. Let's do this. Let's see what's going on. It's probably just okay. So let's look at the frequency again. There's 1, we're given 0, 1, and then 2, then 3, and then 4. 3, good. 4. What's wrong? What happened here? Oh, we loop through everything, right? So it's giving us 5 now. But shoot. So we shouldn't actually have been. Yeah, okay. So the issue is that I'm just looping through the. We don't actually have to stop at pretty much. Wait, funny enough, I didn't even use. Yeah, it's never gonna reach here. I see. But don't worry, I'll work out of it. Here, I guess we need a flag. And this flag is going to check if it's can't spell false. No, this is flag equals true. So it's okay. So here I'm checking if it works, it's good, right? Else, and I guess we can break here too. No, wait, is it true? No. We're gonna keep checking. So in the case where we're checking all the way, every single element, and if it doesn't work here, flag is false. And once we jump down here, we're gonna check if flag. Then I'm gonna break out this case. Break out the while loop. Oh, here flag equals true. I've been solving this problem for like 40 minutes now. It's not even a hard problem. It's just it's implementation heavy. Let's try it one more time. Hopefully, oops, wrong. What's this? Okay, so it's 0. That's obvious, right? Because there's nothing. Wait, no, this is not true. So, wait, why is it true? Hold on, let me see. I times x. X is 6. I0 is 0 greater than max. It is. Okay, there seems to be an issue. Because this is not supposed to be 0. I don't get it. Let's try one more time and see why it's giving me 0. Okay, that's 1. Interesting. Oh wait, that's 50,000. Okay, that's too far. Come here. 12, I guess. 12 here. Nope. Now let's see. Is 6 in this array? Absolutely not. So let's look for it. Let's look for it in the array now. Now it's hold on. This is actually this is a problem. So we have to loop through the whole thing first. But we're not looping through because the first instance, because max could be 0. So we have to actually give it a try first. So this case right here. Do I just make sure if it's not 0, I guess? Really weird way of doing it, but let's try again. It's gonna be 1 then, isn't it? Because it's gonna be 6. I am stupid, aren't I? Add X as well too. This is oh wow, I really messed that up, didn't I? I'm confused. What the hell's going on? Okay, so frequency of max is 0 in this case right now. Oh yeah, that's true. 1 is here. Right. 2, that's true. 3, that's true. 4. Now let's try again. 4. Let's look at it. Let's look at the frequency array. 4 is in there actually. 4. This is true again. So 5 is not there. Remember. So and 5 you can kind of derive 5 by and 2. Okay, looks like yeah, that case works, I guess. I don't know. Let's see. Oops, no, it's giving an infinite loop. Let's see why. This way of debugging is so ghetto. I got fucking hell. Well, so it's pointing here, right? Yeah. Let's just this. Oops, no, just do this. And we just want to see where n stops. What's going on? Oh, this? I just fuck up. X equals 5. A is true. Good. Everything is right. Now let's try it. It stops here for some reason. Is it missing a value or something? Min? I am lost in this case. One more time and see the issue. Certified. Boom, stops. Interesting. Ouch. This is weird. It does that sometimes. I don't know if it's because of DDB or it's actually an actual problem. But let's see. It'll be irritating if it is an actual problem. So it isn't. It is a thing. What's going on here? This works. It's crashing? So I guess I gotta go here and see what the issue is. So NX, this is true. A is N. N is equals 4. Wait, did I? Oh, there you go. So this is all true now. Oh. I don't understand. Wait, I think it's here is the issue. Let's see. Cause it's max is 0, by the way. Wait, okay, so in this case, it actually jumps into, you go to the function, x and equals 50, which is weird. Why is it 50? Let's see what happens in this case, because it just stops. Oops, no. Just one right here. Now it goes here. Let's do it one more time, and I don't understand why it's 50. It should give you like a really big value. Oh, that's why. Oops, wait, does it work? No, it does not work. Well, let's see this shit. Yeah. I was like, why is it 50? Because it's 100, and 100 divided by 2 is 50. Let's see. The issue kind of lies here. I equals. What the hell? Why? Oh, it's because it's. Oh, shoot. I don't know what happened to I, but it seems just to be a programming problem, looks like. This should not be I, this should be J. How did my other two pass with that severe problem? Let's see. Okay. So max is 0, remember? And it's j times x. What's j times x greater than equal to max does not equal 0. That means it's going to go one more time. Now, it's greater than 0 now. So, wait, what? Max is 0. J times x. Oh, max cannot be equal to 0. That's why. And it's okay. I think that functions the problem itself, but we should not be doing that. And it stops here. Oh, it's not fucking. It's just J here. Dude, these little debugging things are messing me up. 460. Okay, so it works now, which is the right answer. Let's try it. I'm gonna look at C real fast. Easy version. The constraints of Q are different. This version Q equals 0. You can make hacks if only. Pretest 2 is wrong. From the looks of these, I mean, there's too many errors in this case. And I'm like shaping this thing up. But I think algo is correct though, because algo is like, I think it's just this problem that's the issue. I'm gonna look for a way to, I guess, filter it. So let's just fix my algorithm because I think I have a subtle idea because I'm too fixed on that and on that kind of implementation. Let's now, because I know exactly what I'm doing now. Let's just get max equals 0, and max is lesser than what is it? We want to try every single max from 0 to what is it? From 0 to honestly 1e9. Yeah, that's okay actually. And then we're checking if it's possible, but I think checking if possible is actually not going to. I think that's actually log. I think that's actually log n plus a, log a plus. Okay, I hope this is not cheating. So it wasn't even gonna work in the first place because the loop is actually wanting on. I can't do that. So a binary search does not work at all. Womp womp womp. Okay, so I think yeah, I think it's the contact time Lexi is making it because that tricked me a little bit. Okay, that's bad because I'm doing B now. C1. Well, since B is taking me a long time to do, let's look at the standings. Let's see. Okay, people are struggling. People are struggling with B now. People. Hmm. Because so B looks like we can already solve a binary search. We can. So when it comes to max, I guess well, given that the length of the array is well 2 times 10^5, max highest value can only be from 10 or 2 times 10^5, right? Or times 2. That's highest max can be, right? So I think that's kind of how we need to loop. That's as far as you need to loop for, regardless of the number is. So if x is, it doesn't really matter if x is a higher or lower number. That's how many. That's as many times they're gonna loop. So I guess knowing this, let's look at the binary search again. Binary search is. I think binary search would work actually. Given that now we know that we're gonna. Yeah, binary search would work actually. Now I think about it. Mm-hmm. Okay, so yeah, binary search would definitely work. Let's look for a way to, I guess, check the max right now. So max is going to be 0. So it's going to start from 0 and we're 0 to 1, or 2 times 25, that number right there. So we can just do, dude. So whatever. So we're going to look, if it's there, right? If it's there, that's good. If it's not, then we're going to look through, we're going to do, I guess, function search. So in this case right here, remember that we're trying to look for, so given 0, 1, 2, 3, then a question mark right here. Let's take this question mark and then, so let's call this A for the time being. Let's call this A. So whatever A minus whatever X is right now, right? We want to look for this throughout the here. And let's pass it by memory, by the way. Because we want to update this for sure. So, I guess. Do we just keep going by max, I guess? Right? Yeah. So remember that we're trying to look for here. We're gonna, and this I think A in this case is gonna be max, I believe, right? Max. So in this case, I'm passing max. Max is going to be max minus now I times X right now. Now, if its value is greater than 1, because we need another instance of it right now. If it's not greater than 1, right? We keep going forward. So if it's greater than 1, we basically remove the one we're going to. And from this case, from this going on, we can, since we know that 1 is there, and we also did max plus plus. Actually, hold on. We just if it's max plus plus and present. Yeah, it's gonna be next plus plus, so we can just return true. I guess am I iterating too much? Yeah, I think this will be the case, right? Because if it's greater than max, we can't really, it's like, this is going to be negative. I think it can be equal as well too. Because if it's equal, right, I times x, let's say, yeah, it can be equal to, that's right. Now this is always going to return true though. So in this case, that if you don't, now let's try it. Please no bug, please no bug. Okay, good. Thank God no bug, but it's the wrong answer. Oh my God, I think I'm gonna solve this problem and that'll be it. Oh, yeah, this is true. Oops, I forgot. It's not the value is not that big. 24, 11. Wait, 5. 2. 2 works, right? Wait, what happened here? Sorry. What? What's up? What happened here? Oh. Issue. What the hell? Oh, I'm just pressing F9, which is odd. Okay, so 5 does not work. This should. 2, this is true. 3 and 4. Now mid is, what's mid now? Mid is 3. This should work too. Let's see why it's not working. Ooh, I think it's cause wait, hold on. I think it's cause frequency is let's see. The first one has 2, right? Nope, it's straight. So 3 should work here. Let's see. L is 3, R is 4. Let's see why it's not working. Can I step into it maybe? There you go. The weird stuff. So L is 3, R is 4, I believe, right? So let's set a point right here. Alright. Oops, L is 3. L is 3. R is 4. Um, 3 plus 4 is 7. 7 divided by 2 is here. Mid 3. There you go. Let's try it. Let's see. Max is 4. Is 4. What? What the hell? What happened? Let's do it one more time. It went past it? I'm confused. Oh, no. Did I? Yeah. That's mid is. Three, I believe, right? Like 0? Let's see. Oh. I'm stupid. I'm over here, like, adding, like, multiple times. So because the mech is already here, we don't need to So if max equals 0, like there's no value for it, we basically do this. Dude, I am super tired. I'm gonna solve this. I'm gonna call GG's. It didn't work because I was cheesing my way through things. Okay, it works now, which is great. All right, let's see. Am I gonna pass it? Yes or no? Oh, I should show you guys here. Wrong on pretest 2. No. I think my algorithm is correct, but again, test case is showing me it's wrong. Do I just call quits? I think I should. Well, that's it, I guess. Only solved one. Yeah, I should be coding a lot more. Well, see you guys later. Adios.